Hello friends, welcome back to Online Math. So we have this interesting equation right here. So this is 4 power n plus 3 power n is equal to 91. So how are you going to be solving this? And as usual, if you can solve this, you can actually pause this video and solve it and then see what answer you're going to be having. And afterwards, you can check out the video and also see the method we are actually going to be using to solve this, and perhaps you will get new insight from the video. Okay, so having said that, we're going to proceed right into the video. Okay, so first I am actually going to do an operation which will not change the equation. So this is 4 power n, and I can actually decide to multiply this by 1. Okay, and then I will also do the same for 3 power n, multiply by 1, and this will still be equal to 91. Okay, so it is still pretty much same. And then that one I wrote there, I can also decide to write it as 3 divided by 3, okay, plus 3 power n multiplied by 3 divided by 3, and this will still be equal to 91. Okay, so and at this point I'm actually going to be using the rule of indices, which basically say that if you have, let's see, e power m multiplied by n, you can actually write these as e power m all raised to power n. Okay, of course you can also decide to push n inside and then bring m out. Okay, so this is what I'm going to use to simplify this, and if I do that, I'm actually going to be writing these as 4 power n and then multiply by, I can actually write this 3 over n as 3 multiplied by 1 over 3, and then I can also do same here. So this is 3 power n multiplied by 3 and then multiplied by 1 over 3. Okay, and this is still equal to 91. So moving on from here, I can then apply this rule. So I'm going to be writing this as 4 power n and then divided by this 3 over here, all raised to power 3, plus 3 power n divided by this 3, okay, and all raised to power 3, and this will still be equal to 91. Okay, so at this point, in order to make the work more convenient, I'm actually going to be setting 4 power n divided by 3 to be equal to, let's say, x, and then I will set 3 power n divided by 3 to be equal to y. And once that happens, this equation right here is actually going to collapse to x power 3 plus y power 3 is equal to 91. Okay, so this is what I have. And then of course, you know that the expansion for this is actually x plus y multiplied by x squared minus xy, okay, and then plus y squared is equal to 91. Okay, and now what I'm going to do is actually to factorize this 91 right here. So if we look at the factors of 91, let me write that here. So the factors of 91 are, we have 1, okay, 7, 13, and also 91, and which means that we can actually write 91 as 1 times 91, and we can also write it as 7 times 13. Okay, we can also write it as 13 times 7, and finally we can write 91 as 91 times 1. Okay, so we want to find out any of this combination that will best satisfy this equation we have over here. But don't forget that our x and y are all integers, and because x and y are positive integers, x is greater than 0, and of course y is also greater than 0. And if that becomes the case, you actually notice that this first term in this bracket will be smaller than this term over here. So this one will be smaller than what we have here. Okay, so that being the case, this is not actually going to be the answer, because 13 is not smaller than 7, and then this will not also satisfy this because 91 is not smaller than 1. So we are left with these two options right here, 1 multiplied by 91 and then 7 multiplied by 7. Okay, so we're going to pick this first case to solve and then see whether we are going to have an integer solution that will satisfy the problem we are solving. Okay, so from here, x plus y multiplied by x squared minus xy plus y squared is actually going to be equal to 1 multiplied by 91. So at this point, we can go ahead to equate the both sides of the equation so that x plus y now becomes 1, and then x squared minus xy plus y squared becomes 91. Okay, so to continue, we can actually square this. So this implies that y plus x plus y squared will be equal to 1 squared. Okay, so that when we simplify that, what we're going to be having is x squared plus 2xy and then of course plus y squared is equal to 1. So I am then going to subtract equation. So if we call this equation 2 and then call this equation 1, I'm going to subtract equation 2 from equation 1. So this is x squared minus xy and then plus y squared is equal to 91. Okay, so if I subtract this x squared minus x squared is 0, and then 2xy plus xy, this will give us 3xy, and of course this is still 0. This will be equal to this minus this will give us minus 19. Okay, so this is what I have at this point. 3xy is equal to minus 90, but this is a problem. Since we said that x is an integer, positive integer, and y is a positive integer, there are no integer values of x and y that when you multiply them by 3 will give you a negative value. So which means that the choice of the factors cannot work. So we cannot get a solution for this. So we are now left with this option here to see whether we are going to generate a solution from there. And so continuing from here, what we now have is x plus y multiplied by x squared minus xy plus y squared is now equal to 7 multiplied by 13. Okay, so that if we equate the both side of the equation, x plus y will now be equal to 7, and then the second term x squared minus xy plus y squared will be equal to 13. Okay, so as usual, we square this first equation. Okay, and then when you expand this, you're going to be having x squared plus 2xy and then plus y squared, and this will be equal to 49. Okay, so that if we call this equation 1 and then call this equation 2, if we subtract equation 2 from equation 1, this x squared will subtract this, it will be gone, and then this will also cancel this. So what we now have is 2xy minus xy, and that is going to be 3xy. Okay, and this will be equal to 49 minus 13, and that will be 36. Okay, so at this point we can just go ahead to divide through by 3, and if we divide this 1 and then this one 12, so that xy will be equal to 12. But don't forget this equation we had over here. Before we squared it, what we had was x plus y to be equal to 7. So at this point we can actually make any of these variable the subject. So if we make x the subject, x will now be equal to 7 minus y. Okay, so if we substitute that here, we're going to be having 7 minus y, okay, multiplied by y is equal to 12. And if we open that bracket, what we're going to be having is 7y minus y squared is equal to 12. Okay, so and when we write that, we're going to be having y squared minus 7y and then plus 12 is equal to 0. And this is a quadratic equation which is also factorizable. So we want to find out two numbers that when we multiply them, that it will give us 12, and then when we sum those two numbers, it will give us minus 7. And so the factors, or the two numbers that will do this work, are 3 minus 3 and then minus 4. When you multiply both of them, it gives you 12, and then when you sum two of them, it gives you minus 7. So moving on, I'm actually going to use that to replace the sum to replace minus 7y. So I'm going to be having y squared minus 3y minus 4y plus 12 is equal to 0. Okay, so y is common here, factor that out. So y is going to remain here, y minus 3. And then minus 4 is common here, y. We factor out minus 4 here, minus 3 will remain, and this is equal to 0. Okay, so this is now y minus 4 brackets. I'm gonna pick one of these brackets, and this is what I have. So using the zero product rule, it is either y minus 4 is equal to 0 or y minus 3 is equal to 0. And for both cases, this will imply that y is equal to 4 or y is equal to 3. So this is what we have. But then don't forget that we actually set our x to be equal to 7 minus y. So if we replace the values of y, for y equal to 4, our x is actually going to be 7 minus 4, which is equal to 3. And then for y equal to 3, x will now be equal to 7 minus 3, and that will be equal to 4. So if we write the solution set, and so if we write the solution set, we're seeing that x comma y is equal to 4 comma 3 or 3 comma 4. Okay, so these are the values of y and x which we've got. But then if you remember where we started with, we actually set our x to be equal to the 4 power n divided by 3, and we set our y to be equal to 3 power n divided by 3. And this x comma y, we've got them to be equal to, let's say, 3 comma 4 or 4 comma 3. So if we pick this first one to solve right here, so we put 3 over here. 3 is now equal to 4 power n divided by 3, and then for this 4 is now equal to 3 power n divided by 3. Okay, so how do we now get the value of n over here? So of course the natural thing to do will be to take the natural log, but at the end of the day, you're not going to be having a positive integer for n, because of course our n is still positive integer. So because of that, we're going to reject this value of x and y, and then we can check the other one. 4 is now equal to 4 power n over 3. Okay, and then 3 is equal to n over 3. So for whichever case, this is 4 power 1 and this is 3 power 1. So I can actually cancel the base and then equate the powers. 1 is now equal to n divided by 3. And in this case, I will still do same. Okay, so there's 3 here. So if I cancel the base, I will still have that 1 is equal to n divided by 3. And in each of these cases right here, this implies we're going to be having that n is equal to 3. So this is actually going to be the value of n that will satisfy the problem we are solving. And of course, you may want to find out whether that is true. 4 power n plus 3 power n is equal to 91. So we want to find out whether n equal to 3 will satisfy. So substitute 3 for n. So we have 4 power 3 plus 3 power 3. Will this be equal to 91? Okay, and of course 4 power 3 is 64, and then plus 3 power 3 is 21. Okay, and when you sum two of them, will that be equal to 91? And obviously you can see that 3 power 3 is 27. Okay, so when you sum both of them, this is equal to 91, and that shows that n equal to 3 satisfy the problem we are solving. Okay, so let me have your thought in the comment section, and don't forget to like this video, subscribe to our channel for more updates, and then I'm going to see you guys in my next video. Bye.